Okay, everyone, I will show you how to complete the assignment 3b. So assignment 3b is about the hyperparameter tuning, hyperparameter optimization. So as usual, first we open the portal. Then log on with the given credential. Okay, the first thing I will do is to create the Azure Machine Learning Workspace. We have done this many times. Okay, so just click create. Okay, assignment 3b RG MLW assignment 3b. Okay, so wait for the button to enable, then we click create. Okay, this will take a few minutes. Okay, so the machine learning workspace created already. You can take this screenshot, and then yep, so let me take the screenshot for the first screenshot. And the next one is to create a compute instance. So I launch the studio. Go to the compute, click the new to create the new compute instance. Okay, so Ryan COMI. Okay, so CPU, the cheapest one. After that, next, the rest is just use the default setting. Then click create. Okay, this will take a while as usual. We just close, then after that we check again later. Yeah, then in the meantime I go to the this okay, go to the files, and then 3b sample. Okay, so I'm going to create duplicate, make a copy, then rename this. Okay, make it sample. .3b. Okay. Yep, this is the machine learning workspace. Okay, then compute instance. After that, create the hyperparameter optimizations pipeline. Okay, so we back to the this. Okay, then we go to the data. Oh, sorry, go to the designer. Then we're going to create the pipeline. Okay, so we're going to create a new pipeline and name it auto price training. Okay, then we're going to pick the data, which is automobile price data. Okay, here you go. Then after that, so we have been using this in other uh, assignment, so we have seen the data, but in case you want to see, then you can just right click and preview the data. So we're going to create a regression to predict the price, this one, yeah. And this time we're going to implement the HPO, or the hyperparameter optimization. Okay, so let me close. Then after that, as usual, we choose the select, yeah, select column in the dataset. Okay, then open the select column. After that, choose to select everything except for the normalization. Normalize losses, yeah, so we don't use this because too many missing value. Okay, by name, after that add all, then this one. Okay, so 25 columns selected and one column is excluded. You save it. After that, we add the clean missing data. Okay, so in the clean missing data, we edit the column, and then we going to clean a three column, which are the bore, stroke, and horsepower. Okay, these three column, and then remove the entire row. The rest leave it as default. Save it. Okay, after that we're going to normalize with min max. For the column, we choose the min max. For the column, we're going to use the previous one that I already have prepared, yeah, based on the column name. So you go to the this list, yeah, so the auto price column. Okay, here you go. This is a column that we're going to normalize the numeric value. So use the copy tab text, yeah, tab from the clipboard. Okay, yeah, save. Then after that we save it, then close. Okay, after that we enough, yeah, for the pipeline data preparations. Then before we move to the training model, we configure and submit. Then create a new experiment. You give the name, the MS Learn Auto Training. Okay, so next choose the compute instance. Okay, the rest we don't change anything. click submit. Okay, so everything looks okay. Then we just wait for the confirmation, job submitted, and then succeeded. Yeah, then we go to the jobs and look at this pipeline running. Okay, so we can see from the pipeline the progress. Okay, so this will take a while. Let's just wait. Okay, so the pipeline completed, and we can preview the transform dataset, and you can see that all the numeric value already been converted into the value min-max between 0 and 1, and this is the price that later we're going to predict. Yeah, this is the actual price, and we're going to create machine learning model regression to predict this price. Okay, so we go back to the designer. Okay, we're going to add the split data. Yep. Okay, then after that connect this, configure the split to use the 70% for the training, and then random set 1, 2, 3. Okay, then save it, close. Okay, after that we're going to add the train the model and tune model hyperparameter. So the algorithm, we're going to choose the boosted decision tree regression. Okay, boosted decision tree regression, this one. Okay, and then after that we're going to use the tune model hyperparameters. So the difference between the train model and then tune model hyperparameter is in the tune model hyperparameters, it will not use just a single value, but it will try the combination of the few parameters to look for the best result. Yeah. Okay, and then score the model, but because before that we're going to edit the column. Yeah. So here in the tune model hyperparameter, we're going to configure the setting is the parameter sweeping mode is using the entire grid, and then after that based on accuracy, and then the metric is a root mean square error. We compare this one and look for the lowest root mean square error as the best model, and the label column is the price. Okay, yep, so save it. Okay, I think price is lowercase. Yep, so this one for the tune model hyperparameter. After that we save and close. Then after this we score the model. Okay, then link this one. Okay, yep, so the train data set here, and the testing is here. Yep, so it's like this, and we save it. Okay, then Yep, we're going to run. So use the existing one and then submit. Okay, so this will take a while. Let's go to the jobs. After that, see the latest job. Okay, here you go. Yes, okay, splitting the data. We can see how the progress here. It take a while. Okay, so the tune model hyperparameter will be taking a little bit longer time because it will basically trying trial and error, yeah, multiple value to get the best model, which is with the lowest metric. In this case, is the root mean square error. So just wait for a while. Okay, so the tuning model parameter is completed, and now waiting for the scoring the model. Okay, done. Then we want to see the result. So preview the score data set. We enlarge. Yeah. Okay, scroll to the right, and you can see this one is a score label, and this is the price. So this is the actual price. This is the predicted price. Okay, there are some differences here. Some the difference is not too big, like 9,893. This is 9,233. So there's about 660 difference. This one is 14,000 and 22,000. So it's about 7,900 difference, yeah, and so on. Okay, so this is the comparisons between the actual price and the predicted price in a score level. Okay, you may want to evaluate the RMSE and so on, but I slightly modify the lab by using the normal train model, yeah, without the tune parameter. Yeah. Okay, so I'm going to go to the designer. Okay, then here we slightly modify the training. Okay, so here yep, so we add the evaluate model. Okay, so add to the left side, and then we add the normal, so the same booster decision tree, but then we add the train model, yeah, train model, the normal one. Okay, then after that bring here, and the data set we bring here, and then we add the score, the model. Okay, so in the train model we choose the label column price. Okay, save it, close. Then after that pass this data here, and then the testing data set we pass here. Okay, and then after that the score data set we put to the right. So we compare On the left is a tune model hyperparameter or HPO. On the right is the normal training, yeah, with the boosted decision tree regression. This one. Okay, save. Then we run again. So this time maybe you want to create a new train automobile MS learn train okay, then after that automobile HPO. The name is up to you, yeah. Okay, and then yeah, so click next. Then after that review submit. Okay, submit. Okay, so we training two model. The first is using the tune hyperparameter optimization, and the second one is using the normal algorithm. Okay, so let's go to the jobs, and then after that look for the HPO. Yeah. Okay, this is the instance currently running. Okay, good. Yeah. Okay, so training this one almost done. Okay, we want to minimize a bit, yeah, to see everything. Okay, so hide this one. You notice that the previous instance that completed, it won't be repeated, yeah, so it won't be executed because exactly the same. We didn't make any changes, so it will be using from the cache. And this one was done before, yeah, so we only need to run the second model. Okay, so now is evaluate both. Okay, so running the evaluate model and then comparing between the tune model hyperparameter HPO and also the normal train model using the same algorithm. Okay, just wait for a while. Okay, done. Yeah, so now we can right click, after that preview the data. Okay, so there are two rows. Yeah, mean absolute error. This is the top is the tune parameter. Yeah, hyperparameter. Below is the normal. Yeah, so the mean absolute error. The model that created using the hyperparameter tune model, yeah, then is lower. The RMSE also slightly lower. Yeah, so overall the error is lower to use this hyperparameter. Yeah. Okay, so that means that the tune model hyperparameter is giving you the better result. Okay, and this meaning that basically we achieve the objective of the tuning model hyperparameter, which can generate the model with the lowest error. Yeah. Okay, so this is the setting. Run setting. Yeah. Okay. Okay, so this is showing you how the benefit of tune model parameter. So some parameter we can find the best value by using the tune model hyperparameter. So the model generated is the lowest error, better than the the other alternative. Yeah. Okay, so I have shown you how to configure or to complete the assignment 3b, the HPO or the hyperparameter optimization for the regression. Don't forget to delete the machine learning workspace after you complete it.